Assalamualaikum. Today I would like to present my lab experiment about discrete damped wave. In this presentation, I will observe how different damping values affect the wave amplitude over time. The main objective of this experiment is to understand how damping causes the signal to gradually decrease and lose energy. We will compare several damping values, which are alpha equal to 0.5, 1, and 1.5. Okay, for the first damping alpha equal to 0.5, the graph we will get like this. This graph shows the discrete wave with damping value 0.5. Because the damping value is small, the wave still has a large amplitude at the beginning. The signal decreases slowly over time, so the oscillation can still be clearly observed for a longer duration. This means the system loses energy slowly. The wave pattern is still stable and continues repeating before gradually becoming smaller. So next, we will see if alpha equal to 1. This graph represents the wave when the damping value is 1. Compared to the previous graph, the amplitude decreases faster because the damping effect is stronger. The peaks of the wave become smaller and time increases. The oscillation still exists, but the signal fades more quickly. This shows that the system is losing energy at a higher rate compared to damping 0.5. Then, with a damping 1.5, the graph shows like this. This graph shows the discrete wave with damping value 1.5. Here, the damping effect is much stronger, causing the amplitude to reduce rapidly. The oscillation becomes weaker after a short period of time. The wave cannot maintain its original height for long because more energy is observed by the system. This graph clearly shows that increasing the damping value causes the signal to disappear faster. In conclusion, for damping value 0.5, 1, and 1.5, the graph shows that the wave amplitude decreases over time due to the damping effect. As the damping value increases, the signal fades faster and the oscillation becomes weaker more quickly. This proves that higher damping causes the system to lose energy at a higher rate. Next, we will continue for this graph. Next is damped sinusoidal wave. This graph shows a damped sinusoidal wave. At the beginning, the wave has a high amplitude because the amplitude value is 100. The signal oscillates in sine wave form due to the sine function in the equation. However, because the damping value is 5, the amplitude decreases very quickly over time. The exponential term causes the wave to lose energy gradually, making the peaks become smaller and smaller. The angular frequency 10 pi controls how fast the wave oscillates, while the phase shift 0 means the wave starts from its normal position without any horizontal shift. So, this graph proves that damping causes the wave amplitude to decrease over time. Because the damping value is high, the signal fades quickly and the oscillation becomes weaker in a short period. This shows that stronger damping causes faster energy loss in the system. For the last one, I will present exercise 1.3, which is about discrete damper wave. So, for this experiment, it shows how different damping values affect the amplitude and oscillation of a discrete signal over time. For the parameters, amplitude is 100, angular frequency is 10 pi, and phase shift is 0. The damping values tested are 0.5, 1, 1.5, and 2. For the discrete damping 0.5, the graph shows the discrete damper wave with damping value 0.5. Because the damping effect is small, the amplitude decreases slowly over time. The oscillation can still be clearly observed for a longer duration. The signal still maintains high peaks at the beginning before gradually reducing. This means the system loses energy slowly. Next, for damping 1, this graph represents the wave when the damping value is 1. Compared to the previous graph, the amplitude decreases faster because the damping effect is stronger. The wave peaks become smaller as time increases. The oscillation is still visible, but the signal fades more quickly. For the value 1.5, the amplitude reduces rapidly because the damping effect is stronger. The oscillation becomes weaker after a short period of time. The wave cannot maintain its original amplitude for long because more energy is absorbed. For the last graph, it represents the wave with the highest damping value, which is 2. The amplitude drops very quickly right from the beginning. The oscillation almost disappears after a short time because the damping effect is very strong. Only a small oscillation can be observed at the end of the graph. In conclusion, all graph shows that increasing the damping value causes the wave amplitude to decrease faster over time. Higher damping causes the signal to lose energy more quickly and makes the oscillation disappear in a shorter duration. That's all my presentation. Thank you.